Okay, so we're just looking at the second video on deriving with exponential functions, and we're just going to go over the two rules again that we've used before. So the first one is the product rule when you've got two functions that have x in them. So you've got u times v, so it's u v dash plus u dash v. And in the quotient rule, u over v becomes v u dash minus u v dash over v squared. So they're the rules we're going to be using. Okay, so always remember to simplify your answers by factorising. Okay, always look to factorise at the end. And especially with the quotient rule, never expand out the denominator. And the other thing is, a lot of your answers are going to have e's in them, and like might have actual values like e squared. Don't convert them to decimals, just leave them as e's, and you'll see that in the examples. Okay, moving on. Okay, so let's have a look at this example, and we're going to look at this actually xex on the last slide as well. So find the derivative if y equals xex. So we've got two things, both with x in it. So let the first one be x, let the first one be u, second one be v. So we've got u dash equals 1, and from the first video, ex stays as ex. And so the derivative, and we just do the cross in between. So we've got xex plus 1 times e to the x, and this is where we factorise it. So e to the x is common to both terms, and leaving behind x plus 1. Okay, and we're going to use that answer on our last page as well. So if you leave it like that, as this answer here, you're going to suck a half mark penalty at least, because you've got to factorise. Okay, so copy that and come across when you're ready. Okay, so again, I'm just trying to change it up. So use the quotient rule, and instead of using y dash, I've used dy dx, just to try to keep your mind active. Okay, so we've got a quotient. We have to use the quotient rule. We can't use any other rule because we've got two things. We've got a fraction both with x, so let the top be u, let the bottom be v. And so we've got, again, x becomes u dash is 1, and this just becomes e to the x. Okay, and so y dash, okay, so put our cross in between. So we go v u dash minus u v dash over v squared. So don't expand, just leave it. So we've got e to the x minus 1 minus x e x over e to the x minus 1 squared. Now the top line can't be fully factorised, so you can leave it like that. There's I hate to say that in any textbooks, like theoretically, technically, you got e to the x 1 minus x minus 1 over e to the x minus 1 squared, but that doesn't help in the answers. So look, I would just leave the answer like that. Okay. I probably wouldn't mark you wrong if you kept factorising, but there's no point in factorising because you can't cancel anything top and bottom. Okay, copy that and come across when you're ready. So just another example. Rather than finding a derivative, we're actually going to find the gradients. So f dash 3 is the gradient at x equals 3. So f dash is going to be the derivative, and f dash 3 is the gradient at x equals 3. And again, I'll just make it a little bit complicated. I've got a product rule. So why don't you guys have, oh no, I'll do it for you, that's fine. So I've got u equals x, v equals e to the x squared minus 1, u dash equals 1, v dash. Now this time we've got to multiply by the derivative, so that's going to be 2x, and then e to the x squared minus 1. Just remember, that's like another function, so we have to do f dash x e to the fx. And put our cross in between. And so f dash x, we'll use that notation because we've got f here, so we'll do f dash x. It doesn't matter which order we do. Got x 2x e to the x squared minus 1 plus e to the x squared minus 1 times 1. Now, because we're substituting a value in, we don't need to factorise because we're just going to put it in anyway. So let's just try that. So we're going to put 3 times 6e 3 squared minus 1 plus times 1 doesn't change anything, e to the 3 squared minus 1. So we've got 18e to the 8 plus e to the 8, and that equals 19e to the 8. Now don't put a decimal. Answer. Okay, e to the 8 equals a number, and so 19 times that would equal a number, but 19e to the 8 is the exact answer. So especially when you get to like maybe equations of tangents and things like that, don't convert, just leave them as e's. Okay, so this next one is I've plotted on Desmos y equals xex, and the point is I'm trying to find a turning point and prove that it's the minimum turning point. And so just going back, so when we had xex, it was ex x plus 1. So let's just bring that forward. So y dash equals, oh, I've forgotten already, ex x plus 1, ex x plus 1. So at a TP, y dash equals 0. So 0 equals e to the x plus 1. Now, as we've learnt, e to the x can never equal 0. It is an it asymptotes to 0, but it can never equal 0. So therefore, x plus 1 is the only place. This is the only place where it equals 0, because every exponential can't equal 0. And so x equals minus 1. So that value there is x equals minus 1. And then we just put it back into y. So at x equals minus 1, y equals minus 1 e to the minus 1, and that just equals minus 1 over e. So the turning point is minus 1 comma minus 1 over e, which you can see it is a negative value here, so that value there is minus 1 over e. Note that I've turned the negative indice into a positive indice, and you don't convert that to a decimal. And then, strictly speaking, we need to prove that it's a minimum TP. So we could use the second derivative, but that means I'd have to do a derivative of a derivative, and that's not going to, that one there, I'd have to use a product rule again. So I might just use the first derivative test. Okay, so if I've got a negative gradient on one side and a positive gradient on the other, it's a min TP. And so a value to the left hand side, maybe x equals minus 2, and a value to the right hand side, maybe x equals 0. That'd be easy. So I'll do that one first. So y dash, when x equals 0, that becomes 0. So one time, okay, e to the 0 is 1, so y dash is a positive. And when I put in x equals minus 2, I've got e to the minus 2 plus 1, and that's going to be a negative number, so that's minus 1 e to the minus 2. So I've got a negative and a positive, so I've got a min TP. So in this particular case, the second derivative, I could use the second derivative, but it would take me a few calculations, so it's easy to use the first derivative test. And so if you have a negative to a positive, it's a min. If you have a plus to a minus, working left to right, working that way, you have a max. Okay, but we had a negative to a positive, so that's a min TP, which you can see is a min TP there. There would be a point of inflection, okay, where the concavity changes, perhaps, but we're not going to worry about that in this particular video. Okay, that's it. Bye.